You need to note things. I think it's actually more like data harvesting. So hello, is Gaurav here? Okay, so our pre-planned note taker actually is on some sort of an escalation call right now. So is there like another volunteer? You, Ignas? You? Microphone? Ah, I need to swallow them. This better? Perfect. So we had pre-planned a note taker, and unfortunately the person actually is on some sort of an escalation call. So we are looking for another volunteer right now to actually take notes, and another volunteer for being part of the jabber. So anybody willing to pick up that particular task? Wow, everybody's looking at their screen, looking everywhere. You can, okay, we found a jabber scribe, okay. Anybody willing to take notes? It would be very appreciated. I'll give you a free Coke. Ignas? Okay, thank you. Okay, so let's get started because we do have a pretty intense agenda today. So first, some administrivia, and so that is the quick agenda here. So you probably have seen this thing by now already a few times, the note well. Keep in mind, even though you have seen it a few times, whatever you say, it's going to be recorded, it's going to be public record, and be, aware of that. So, give the note well your attention. We have also given around the blue sheets. So fill those things in, then at least we know and we have an idea how many people actually were here, which again, is one of the data metrics which we intend to capture for this particular BOF session of DC routing. So the next 2.5 hours, we do have a pretty intense agenda. We have a lot of topics to talk about. Some of the elements will, we have the expectation that there will be lots of Q&A and discussions, going around, and all that actually, is pretty nice. So we're going to be covering first like a few presentations and discussions around the requirements and the problem space. That's going to be followed up by some people. I'll be looking into some of the changing requirements from the routing perspective, and they have been looking into like new protocol work on how to address that. So how to make like new tailored solutions for this changing problem and requirement space. Now, that is going to be followed up with another approach where we actually, or where people actually have been looking into augmenting existing technology. So not really tailor-made, but, use what we have, augment it for this changing, data center routing, environment. And then at the end, we're going to do like a quick wrap-up, of where we are. So now, because me and Victor, we have been wearing these badges, like, ask us about the BOF. So now, before we actually start with, these birds of a feather about data center routing, I want to make clear that everybody in the room understands, what is the intent of this particular session here. So the main intent here is to actually, provide our, wonderful area directors, with input, which they can actually use, for potential future actions, regarding the developing problem space for data center routing. And in addition to that, we also would like to get like better understanding what are the modern data center needs with respect to routing, management, resiliency, programming, operations, traffic flows, and so onwards. Also, it is not the direct intention of this particular BOF, it's a non-working group forming BOF, that there will be, as an outcome, a general DC routing working group. Now, that may be a result of this, but that does not necessarily have to be the case. So, what is the key question we're trying to address here? And the way we look into it is that, for us, as a result here, we're trying to understand, if it makes sense for the IETF to actually increase their focus around data center routing and the operational specifics. So what we expect is, from you is to actually receive some guidance and input to understand some of the leading indicators, of change for the routings in the modern data center environments. Also, in addition, it is not the expectation that from any of the requirements that we gain consensus on the requirements as they are right now. So what we're trying to understand here is if these requirements, go towards the, the environment where, that there are changes from the traditional one environment, so that the needs from a data center, routing perspective, are different from the traditional one routing environment. And also, another assumption we are making is that, the potential to augment existing protocols, that should not exclude potential work upon new protocol work. So this actually means, that we may actually do some things, in parallel at the same time. We may actually, want to work upon augmenting existing protocols, but at the same time, why not actually, create some purpose-built data center, data center environment, routing technologies. So now, to conclude, the intro section here. So when going through the BOF here, I want you to think about this, following aspects. So the first thing is, if you do Q&A, please be concise. We don't have that much time, and we have a lot of content to cover here. So the questions I want you to think about, and for which we're going to be asking your feedback, is, are the data center requirements clear enough to justify, additional IETF focus, or what else actually is needed? And again, it is not our intent to create like full BOF, consensus on everything. Another question you need to think about is, would it be, can a single solution actually achieve all of the requirements? So that is something to think about. In addition, do you have interest to actually work upon the solution space if there are like, different sets of requirements, for you available? And as a last one is like, how should IETF organize, the working upon the solution space environment? So that means, should we just leave it as this right now, nothing really dedicated? Should we create like, like a data center routing working group, which is like covering general elements? Or should we actually, really carve up a set of requirements and then follow them up with the solution space, protocol work as such? So I think that is what I wanted to say here. So I think, Jeff. I have a clicker thing for you.
Good morning, everybody. It's great to be here. Put a lot of work and effort to make this happen. Thanks to our ADs to make this happen. So we've started about a year ago thinking about what is it, how data centers are different than the rest of our network, what's been done before, what needs to be done in the next few years. We formed the team, and not because we are long-time friends. We know each other, we trust each other, we respect each other. However, the criteria was, we are people who know how to design protocols. We are people who know how to operate networks and how data center looks like. So if you look at outer list, most of us well known here. So hopefully we can represent wider community in IETF and outside of IETF. So why do we feel the requirement draft is needed? We really want to avoid the beauty context. We've seen this kind of debates. My LSAs are better than your LSPs. And if I run the internet, I can run anything else many times. The idea here is to create a single set of requirements and definitions that every contender or any potential solution could be compared against. So really to avoid beauty content. And it's not a finished definition. We are just starting. We really need your help. No network is alike. We really invite you to provide your comments, your unique use cases, something that what we try to define doesn't meet your requirements. Please be vocal. There's list. You know where to find us. So first few slides are the definitions of the fabric. This is what we see today. This is what we see happening maybe within a year or two. We know new types of silicon are coming that will provide some new functionalities, some next year, some 3 years from now. So we've tried to provide high-level set of definitions that identifies what DC fabric today. So to be very clear, fabric provides basic connectivity. So we receive many questions. Is it EVPN? Is it Lisp? Is it something more fancy? It is not. It's really basic connectivity. If you wish to run EVPN on top, it's an overlay service which still requires reachable next hop. And this next hop will be delivered by the fabric. From domain separation within the fabric, it's not provided by the protocol itself. It's provided by an overlay if needed. Right? So we are not looking into separation within the fabric. So some characteristics we've seen, and again, many people who have built rather large data center, we've gone through probably 50, 60 iterations of initial draft, contributed to this. So hopefully this is something you can identify yourself in. The fabrics are mostly regular. They're repeating itself, and they're usually recursive. Very high bisexual bandwidth and path diversity. 5,000 paths fan out is not unheard of. That's what we see. Today, most data centers are ECMP based, meaning we've got many, many different paths to the same destination and can load balance per flow. However, it's just an anomaly of certain graph characteristics. So non-ECMP paths are possible and should be supported in the future. And again, here we are looking into next generation of silicon, which will make us able to react perhaps on QDEPs, perhaps on some other characteristics of the network that are not available today. Limited physical diameter is important. What we see today is no more than 80 kilometers between data center within the metro. And fabric could be within this location. However, we see more and more requests to extend fabric beyond single physical location. So it's not unthinkable of having fabric extended over metro link. So it's not classical DCI in a way. It's really stretched fabric, and such construction should be supported. Another very important property is very tight propagation time, which is much shorter than desired conversion delay. We will see a number later, which gives ability to build protocol in a way that the conversions within protocol itself is shorter due to very short propagation time. Going from traditional closed fabrics where every endpoint is equidistant, so you know exactly the time it takes to get from one point to another and back. We're seeing more and more data centers where paths are asymmetrical. So path to one destination could be longer than another one. Return path again might be different than forward path. This should be accumulated in when designing new protocol or extending existing one. And link state, obviously, number of links is significantly larger than number of nodes. This should be well understood when we think scale, when we think convergence time. To convert what just been said to requirements, we believe Fabric must support non-equidistant endpoint. So it's not classical today's data center where everything is exactly the same number of hops from each other. Since spine and leaf today is the most prevalent architecture, it must be supported. However, we don't exclude support for anything else. However, it's an evolution. We are not trying to revolutionize data centers. However, as we go and design new topologies, they should be supported. Given the physical distances between metro data centers, particular cases, Fabric might only provide interconnection between two different fabrics, and such cases should be supported. KPIs. So a bit of product management language, but to make it clear, the KPIs we identified here are single dimensional, single failure, and they will be changed. We look from application perspective, what an application can survive typically. We looked at what does it take to propagate a failure, what does it take for control plane to understand there's a failure, process the failure, download it into forwarding plane, and react. So we've provided 3 different set of KPIs based on the size. Probably I'm not going to read the numbers, you can read themselves. We would really like you to look at them, compare them to your use case, and see whether they meet your requirements. Do you need something that's faster? Do you think it could be relaxed? It's really call for your input. It's not the numbers we impose on you. And very important, the total convergence time, it's always a combination of number of routes, number of paths, and time it takes to detect. So we are still looking into combination of different factors, and we'll work out probably more coherent numbers. So if we look at today's data center, we must support load balancing using ECMP, which is the case today. We should be able to support weighted ECMP, where besides metric to the path, we can also provide weight to particular path. And we need to support unequal load balancing as well, based on particular metrics. And those metrics might not exist today as we know them. It might be something new with a new protocol. So we may support any new load metric we are not familiar today with that would bring more granularity. So as we know, fan out is huge, size of flows and number of flows is huge. So load balancing, good load balancing is extremely important. So now we are moving to routing protocols requirements rather than Fabric. So it's a protocol that's going to run on the Fabric, distribute reachability, and make sure Fabric is working. So obviously you want numbers and KPIs mentioned previously to be supported. We see today fan outs of 250,000. We see requirements coming to 512 paths. It sounds large, but it should be supported. We believe there are requirements to do so. Classical layer 3 Fabric distribute IP reachability. However, we believe that the new protocol should be able to distribute any other type of reachability, being MPLS labels, being any third-party data, meaning additional placeholder for metadata. So think about segment routing in data center. Some people think it's really important. So being able to distribute labels or binding from prefixes to labels within the same protocol as we do today in classical segment routing is important. Telemetry is important as well. So if we need to distribute some data that's not necessarily reachability data, but any metadata related with quality, with third-party metrics, the protocol should provide us ability and ease of encoding to distribute such information. And we've been looking into encoding for quite some time. We decided to postpone this discussion. It's somewhat poisonous, but there's definitely interest in new encodings. So what we believe must be supported. Support for in-band and out-of-band management, mandatory. Zero-touch provisioning, mandatory, as well as neighbor discovery that would facilitate ZTP. When new switch is being placed into rack, we really believe that the amount of information that needs to be configured should be minimal. So potentially, switch should be figured out where it is, what it does, whether cabling is done right, and figure out who are the neighbors. We believe mechanisms such as BFD, and BFD here specifically mentioned because this is de facto standard today. There might be something else in the future. However, if you look at what's supported on today's silicon, how we do fast failure detection today, BFD, or ability to track state of BFD that would result in changes in state and protocol is mandatory. We also believe that a protocol should be able to bootstrap BFD session. So when there's no configuration on both sides, we should be able to leverage the routing protocol to provide enough information to bootstrap BFD session that could consistently be used to track liveliness of the link. Operational requirements, so getting more and more interesting because amount of data expected, amount of information expected is growing really with the day. So we believe new protocol must support real-time notifications or near real-time, definitely in milliseconds. It should be able to communicate its state relative to its neighbors to a potentially out-of-band system that could change the graph, recompute the graph, do something with this information. We should be able to request a snapshot at any given time. So when we want to figure out what happened 20 minutes ago, we should be able to look at snapshot that was taken 20 minutes ago, compare it to operational state, and understand what has changed, what has happened, and why maybe we leaked particular routes to the world. Very important requirement is to be able to decommission new node without degradation of operational network. So we are not talking about graceful restart or non-stop routing. We all know the switches, they're complicated, they bring huge amount of bugs, and potentially we would like not to see them. We would like to see an evolution of graceful restart, if you wish. So when we decommission new nodes, it doesn't affect operation of existing network. So there are few items that we looked at. They require additional study, and we would like your input on those items. So non-classical encodings. gRPC, Thrift, similar, so self-describing encodings when rather than trying to encode something in the TLV, we could provide proto file that describes the data. It gives ability to innovate. It gives ability to build things within our own data center. We maybe not require interoperability to do it in minutes, not in months. Ability to function as an overlay. The focus of Fabric protocol is underlay. However, running same protocol to provide overlay services is definitely possible. It will bring new requirements with regards to scale, with regards to livability. However, it's possible, and we will look into it. Flowlet signaling. So flowlet is a subflow of a flow. It requires particular knowledge about interleaving. It requires particular knowledge about how to reassemble flow, so there is no reordering at the receiving side. We'll be looking into it. We believe it's an interesting technology. Multicast. So most people in data center are afraid of multicast or hate it. So there are some requirements for multicast. There is beer that's coming next year. in implementations. So we'll definitely look into how to provide facility to replicate traffic, how to address broadcast and non-multicast traffic in the fabric. Auto-aggregation and conditional deaggregation is a very interesting topic. So most data centers today run low-end silicon. So in terms of scale, you should always watch where you are in terms of number of routes, number of labels. When we aggregate, we can increase amount of state in the network since it's aggregated. However, as a result of aggregation, and there are very good description in BGP and large DC, RFC, about potential black holing and other artifacts of aggregation. So being able to deaggregate dynamically based on particular condition is an important thing in protocols, and we'll be looking into it. State representation, so ability to build graph that could be analyzed upon real-time or non-real-time is important. So to facilitate easily understandable networking graph at scale is important. So I'll be looking into how the networking state could and should be represented northbound. And the last point here is pretty much the consequence. If you want to do traffic engineering in data center, you need something like PCE. Someone has to take the topology, apply the constraints, and compute the path. So integration with PCE-alike entity, or what we call SDMs those days, is important, and we'll be looking into it. Questions, comments? Everybody agrees?
So we have about 10 minutes for the Q&A session.
Hi, Aarti Iyengar, Arista. I'm a little concerned about the requirements doc kind of missing basic problem statement. Essentially, like if you have looked at the MSDC, which you do refer to in the document, what would be good to understand is this is not a new problem, right? Like data center, people have been building, requirements are very varied. And what seems to have happened here is a collection of all sets of varied requirements becoming a God list. Secondly, from a fundamental kind of problem statement, we do not have a requirements document to tell service providers how to design their backbone networks. Data center network design is how companies compete and differentiate themselves, and people run everything from 4-way to 128-way to maybe 512 in the future. Why are we coming up with a set of requirements to standardize? What does it need to standardize the requirements is my question. I'm fine with the proposals. If you're saying that, oh, there is, in one case, you can use BGP, some people run link state, and some people may want to run Rift or the BGP SPF, perfectly fine. But why are we trying to standardize the set of requirements which are so varied across different customers, plus it is their business differentiator, and all these requirements together really don't make much sense as a whole. So that's kind of my comment.
So we are not trying to impose an architecture on everybody saying this is how you are going to build your next data center.
But you kind of are, because you are defining what the fabric is. You are saying there's a leaf spine. Plus, there is certain requirements which are kind of, we are said may, based on what? We've said, for example, DCI is a may, but DCI could be extremely important to some customers who operate data centers. For others, a structured leaf spine, super spine may be fine. So point being, it's just varied, right? Like, and one set of requirements doesn't apply to everybody.
So as I said before, it's not finalized version of requirements that you will go and implement. It's a request for comments. We value your input. There is a list in the DC routing. Please send your comments and we'll try to address them the best we can.
I think sorry.
Just a second. Yeah, please do understand, we are not imposing an architecture. We are gathering requirement that people who are going to build either new protocol or extend the existing one, and the problem space is well known in both IGPs and BGP, right? They could look into and think, hey, my design doesn't address this. Not the DC design, the routing protocol design, because this is about routing protocol. It's not about how you design data centers.
Yeah.
Hope this clarifies.
And I would like to compliment also that, one of the reasons we are doing these requirements, overview is to come to an understanding, that, is it sufficient to just augment, existing technology, or should we look upon like, more tailored solutions, going forward? So a question to ask yourself is basically around that. So this way, is what we have right now, is it sufficient to fulfill these sets of requirements? I don't think it is the general purpose to standardize requirements for DCs, because that is a very hard thing to do and will be incredibly controversial.
Mike?
No, but it is on the informational track to become a standard. So I don't understand. So either it is kind of being proposed as an informational kind of draft eventually to become an RFC for on that track, or it's not, right? So it's fine if it's like a guideline, but it's not. It is actually on the informational RFC track. So that's the confusion.
So the meaning of word informational, it is for information, right? It's not that you have to go and implement in particular encoding and format. This is something we advise because we believe this is, if not the best way, it's a viable way of implementation.
So, sorry, just to add a comment for clarity as well. Remember what Gunter stated in the beginning was, we're trying to understand the leading indicators of what's driving various things in the environments. And so for this BOF is to understand, are these leading us to, like, what is this leading us to understand the environments to dictate for us in terms of potentially new work, et cetera. We're not here specifically trying to say these are the finalized set of requirements. We're trying to understand, where's this leading us? Are there augmentations? Is this significantly different? Are the drivers significantly different that we should look at additional focus here? So we're not specifically going, trying to narrow down on this, but it's good data, right? And we want to discuss, what does this look like?
So if you look at number of proposals, there's definitely, it's not a vacuum. Proposals are coming, they're trying to address limitations of protocols today, right? So it's not something we've invented and imposing to the rest of the world. We are seeing the need for better, more scalable, faster converging protocol that could be either enhanced existing protocol or a new protocol, and we are trying to figure out what is it.
Okay.
So by the way, we're closing the line also.
What's that?
Yeah, go on, but you were
Okay.
the last one on the
You're
line.
going to need more than 10 minutes with Jeff. Anyway, a lot of these requirements, they seem to be all encompassing. It seems like you should at least classify them as being routing control plane requirements or data plane requirements or platform requirements. Because when I saw the list, some of them are closer to routing and some of them are closer to platform. But I mean, it's a good start, I think.
I fully agree with you. So the intention to publish in such a way was to request your comments. After more comments and data have been gathered and analyzed, we'll start structures in a way you can read and say, this is what I want from management plane, this is what I want from control plane, this is what data plane should do.
Well, I think I follow him in this conversation. I follow him what he said. This is a combination of the platform routing and everything else. Maybe you guys need to just split it to different document, different concept, because this one, out of man management, it's really not as much a routing problem than maybe the other things you have in this document. So I think the document, you guys try to put too much thing in one document, which makes it kind of hard to digest and use.
So on one side, I kind of agree with you. Out-of-band management is not a routing problem. However, we are not trying to make it a routing problem. What we are saying that protocol should support out-of-band management. And what it is really up to out-of-band management people to decide.
It's a routing problem. It's going to support the movement of IP. It's going to create a reach. So is it out-of-band management or whatever it is? It's a routing problem. It's going to do it. So it's not really matter of the support. It should be there by default.
Greg, we closed the guy behind you. We closed the line, so.
Dan Bogdanovic, with regards to the encoding, you mentioned particular, frameworks for encoding, but it would be good to say what requirements, we would like to see from the encoding instead of naming specific frameworks. Because, by the time this is done, there might be something new, that might satisfy that, and we don't know what are the requirements that we need from the encoding.
The intention of encoding was specifically to say that there are different encodings than what we do today for routing protocols, and we will be looking into them. It's in no way meant to say those two are the only candidates. It has etc. at the end.
Greg Mirsky, ZT. So you emphasized and called out the role of BFD in triggering conversions. That's very good. I appreciate it. What about degradation of links, paths? So you think that indirect analysis of telemetry, like buffer queue utilization, is sufficient, or there might be some requirements towards the performance measurement?
So we would like to keep functionality of a protocol limited in a way it doesn't increase size of link state database. So again, given ability of telemetry systems today, we believe that amount of information that could be provided with regards to drop packets, reason why it was dropped, queue occupancy is enough to declare that there's degradation, and this is where weighted ECMP could come into play, for example.
Okay. Another question is that, if I understood correctly, you mentioned to routing protocols requirement is distribution of telemetry. So is it to routing or to management? Because to routing, I will then imagine that it will be flooded information. You think that telemetry needs to be flooded in the fabric, or you need to deliver it to certain host that will be do analysis, and digging and such. So it's a little bit different functionality, and I think that then it has to be worded differently.
It's a very good question. Thank you for asking. So the basic telemetry is system to management interaction. I don't think we need to distribute counters across the fabric. However, there's some amount of metadata that might benefit how we load balance, how we choose a path. So finding right balance about what should be distributed versus what should be sent up to the management is yet to be figured out.
Okay, I think I'll take it to the list, but I think that it will be very interesting to really discuss how the flow goes, whether it goes always north and then go south, or there is some east-west.
Thank you.
So distribution of information within the fabric is obviously east-west. Distribution of information to the management layer is north, and amount of information sent north is order of magnitude higher than.
I agree. Thank you.
Randy?
Randy Bush, IIJ. Could you pull to slide 7, please? We provide global transit. We also have massive banks. We also build data centers. We see those as very different things. And I love this slide because this makes clear the delineation between a data center and an enterprise, right? And I was initially horrified at the enormous laundry list of requirements, which, as I posted on list, kind of implies there's something behind them. I don't know if there is or isn't, but I guess in another sense, this being the IETF, if you hadn't laid out the requirements, we'd complain that you hadn't. So what the heck? But it's an enormous list, and I think some focus is going to be needed.
Absolutely. So my first commenter on anything is, please don't try to boil the ocean. However, if 0.0 draft wouldn't trigger any comments from you, any unhappy faces, we wouldn't have done a great job. So it's really to you to read, to figure out, hey, I disagree, I don't like, I know better, and let us know. We are here to listen to you. We are not imposing any of what has been presented. We would like you to assess what's been presented and let us know what you think.
Okay.
Thank you so much and enjoy the rest of the presentation.
So we have 15 minutes for this full slot.
Okay. Hi, I'm Nalini Elkins, and
I'm Mike Ackerman.
and Mike Ackerman.
Morning.
Yeah, hi. If you can hear me, we're just doing this to kind of give a different perspective. If I can kind of, I suppose to introduce ourselves, I mean, I don't want to say we represent anybody. But you can see the people who have written the draft have a large corporate. I don't know if legacy is the word, and so we use the word brick and mortar. These are the people who've been around for a long time, and so we'll talk about that. And if I can give a little bit of history, I suppose it's like I might call us the 99%, and we're probably the 99%, and I don't know what that number is, but we're probably the 99% who are not here at the IETF, but in terms of, I guess, data centers or presence, there's a lot of them. I mean, for example, like Michael, he's with Blue Cross in Michigan, which is a large healthcare enterprise. And we were sitting around. They meet all the healthcare industry, insurance companies. A lot of them, they meet like once every quarter. And I was sitting around the table with him one time, and somebody looked around and said, "That's 10% of the U.S. economy sitting right here." And I myself have a very small software company, and I have probably 2,000 enterprises and data centers that I talk to, on my email list. And I'm nobody, I'm just a little software company. So it's just to kind of give you a little perspective. And we have, I guess, different requirements, and we're not maybe at some of the stuff that you guys talk about with fabric and everything else. It's an aspirational goal for us, but a lot of us are definitely not there. And so just to kind of give perspective on where we are.
And I was just going to say, one of the reasons that we're here is to find out if our requirements and demands on our networks are different than are being taken into consideration today, and to ask the question if they should be. So help us with that.
Yeah, just to kind of round out the conversation. So, okay. So who are we? By and large, very geographically dispersed. That means that, like, he's for example, he's Blue Cross in Michigan. They've got regional offices, all over the state of Michigan. Yeah.
I can say, I was just telling my new friend Linda, that means you have to wake up now. we have the typical setup of data center, campus, and then unique to Michigan is a statewide network, and that's important to us. But we have Blue Cross plans in every other state, and we connect to them via a private network that's called BluesNet. So that may represent a unique set of requirements, and that's what we want to take into consideration.
But by the way, can everybody hear them, or is the audio okay?
Can you guys hear okay? Okay. We can put this up a little bit too. But anyway, so we use the internet for business, but that isn't our business. And for maybe I don't know if the analogy of the 1% works, but for the people for whom maybe I don't know, I may be speaking out of turn, but maybe for the people for whom fabric and all that stuff is a huge consideration, the internet is their business, and for us that's definitely.
And we use a thing called private networks, which is maybe an unfamiliar term here, but that's heavy. And then a lot of business-to-business VPNs over the internet.
Yeah, and we have multiple kinds of networks, and we'll talk about that. And we'll focus on what happens inside the data center, because I know that's of concern. But as I say, we get questions like, why don't you just go to the cloud? And so I'm going to kind of tell you why we are the way we are, why it's really hard to change. Okay. And part of it is because we got in early. We've been computerized for the last 40 or 50 years, not just like the last 5, you know what I mean? There's a lot of inertia. I mean, a lot of stuff to move. Very large IT staffs.
You're saying we have a lot of baggage.
We have a lot of baggage. Yeah. And very large IT staffs, thousands and thousands of people. And what's important in a lot of decisions is, as in any business, is, time to market, return on investment, business reasons. And the business reasons are not how fast can you get your content out onto the internet. It's how many insurance policies can you sell. So it's a very different kind of motivation. So what kind of networks do we have? Usually people have large campus LANs, private WANs, going out to, for example, to the state of Michigan. I used to work for a very large oil company, and we would have, our own private microwave networks in the swamps of Louisiana because there was no service. And so we had to build our own microwave towers. I mean, so we do stuff where we need to. A lot of extranet, a lot of business to business connections, or he'll connect to the government, to Medicare, so on, Social Security. And we do have internet facing apps, but that's, everything is firewalled. But let me show you. But inside the data center, that's because I know that's what we're interested in. What does the inside of our data center look like? It looks horrible. It's tons and tons of layers of servers, middle boxes, and so on. And I'll kind of I'll face this out. Lots and lots of different kinds of applications. Let me see if I can give you.
I'll just throw in that we use the term multi-tier application, which I think is pretty common. And in many cases, it's multi-tier, which explains the messy diagram that Nalini just had up there.
Yeah, multi-tier. And a lot of the pathways go through those layers and layers and layers. And so we have tons and tons and tons of middle boxes, load balancers, NATs, firewalls, app servers, all this stuff. And the routing is going through all that. And if it's equal cost and that kind of stuff, it's all this pathing is done through these kind of things. And the biggest things which you cannot forget is that in so many of these kind of data centers, we have a back end mainframe application. I know it seems unfamiliar to a lot of people, but you cannot take these large mainframes and shift them over to the cloud. I've worked with people for years and years and years, and I've only known 2 somewhat medium-sized companies who are able to do that. And a lot of the data resides on these large mainframes. You'll have a web application, but the back end is the mainframe. And so that's kind of where we're sitting. So let me go back. In terms of the routing protocols we used, a lot of people use OSPF. These guys use a lot of.
I'd say EIGRP is the most prevalent in most of the networks, with some BGP usually on the edge. RIP kind of declining now, I hope.
I know.
And we do a fair amount of static routing.
No, I'm sorry. And it's all different. I'm just collecting this from different. Not everybody does all of this. I'm just collecting it from different people I know. But this is what we do. And what I'm going to tell you too is, like, I asked around people that I talk to all the time. I mean, I talk to these companies, probably 5, 6, 7 of them every single day. And I said, are you guys having problems with routing? Do you think latency is a problem? And everybody says, routing just works. And they have, it just works. It's not a problem. We've got a lot of problems. Don't get me wrong. We've got a lot of problems. That's why we're here in the first place. This isn't one of them. And if you're talking about like reducing link state advertisements or route summarization, any of that stuff, I mean, that's your job. I mean, we know how to do that. That's what we do. And so it's just like, it's not a problem. You want to add to that?
I really don't have much to add to it. I think our situation, especially contrasted to the previous speaker, we're pretty simple, I think. But we're here to provide our requirements if they're meaningful.
Yeah, and we totally, if other people find that they need other solutions or they need a problem, I mean, that's totally fine. It's just, and we don't speak for every single enterprise, every single data center in the world. We're just, I talked to a number of them and they all kind of said, yeah.
And finally, I think I would say is, to the extent that we're not providing the type of input or feedback that y'all would want, let us know what's missing, and we'll go back to our folks and find out what that might be.
Yeah, if we're not saying what you need, then let us know. But we're open. I'm open to take questions if anybody. Randy, do you have something you want to say, or do you guys want to take the mic, or I can finish? It's up to you.
Yeah, so we have about another probably 5 to 10 minutes on this. Yeah, so we can ask them now if you want.
It's fine. Okay. Yeah, because we're almost, it's pretty simple. Yeah, I'm totally open. Randy?
Go ahead, Randy.
Randy Bush, IIJ, 2 comments. One is probably half the people in this room understand what there is to understand so far about enterprise routing. EIGRP, by the way, went away once we got multiple vendors. Sorry. You got to snuggle up to this one. Just want me to do it again? Okay. Many people in this room understand, or at least flail at enterprise routing. EIGRP went away once we got multiple vendors a decade or 2 ago. But I think you have done an excellent job of delineating yourselves from data center routing. And I'll point you again to slide 7 of the previous presentation, right? This is a different problem. It doesn't belong here.
So thank you for your work. I really appreciate it. The time you are spending with us here, it opens a completely different world. Most of us believe in bubble. We assume things are modern, built, replaced every 3 years. In your case, it's very different. It was eye-opener for me. So when looking at what you've been doing, what I really could see is the network has been built in a way that either represents your entire organization or vendor of your choice managed to sell you over the last 20 years. So the intention of work here together is really to give you tools to fight this, to tell next time salesperson or next IT manager comes, this is what we figure out, this is what could work for us, it's a simple, it's operationable, and this is what we want, rather than trying to fight unknown. So it's really to make things known for you. This was the intention of publishing BGP in large GC. So thanks to Aliyah for pushing it through, and I believe we published it in less than a year. It's really to make you aware, to make information public, how things could be done, leveraging previous experiences, so things could work for you, and you have enough ammo to fight sales pitch. Anyway.
Jeff, I really appreciate that, because, and I'll let Mike talk too, but where I think a lot of us would like to go to somehow is, this is kind of how I think we see our future, is we'd like to go to SDN, containers and that kind of stuff, hybrid cloud. We have a problem though, is how fast we could possibly go. We'd love to have some BCPs, some paths, forward best practices on how to do that. Telemetry, we're talking to some people about the kinds of visibility and stuff we need. The problems, because we have some problems maybe that others might not have, which is that we need to encrypt inside the data center. We have regulatory requirements for separation and visibility and so on. And we have tons and tons of applications, some which were written, as I say, in the Stone Age of computing, which are very difficult to convert. And we have relations. Yeah.
And expanding on one other thing that you said, we're very heavy into the need for management and monitoring and telemetry and whatever else that might hold for us. So.
Yeah. Yeah, but we would very much like to have guidance and best practices and work with people. If there's somebody who's ahead of us, great. We're all
I'd
here.
ask if there's anyone who's not ahead of us. But we want this to be as much of a two-way street as possible. We're going to learn a whole lot more from you than you will from us. But to the extent that our requirements are valuable, great. I'll echo what Nalini said about we're somewhat anchored in the past. That kind of hits at what Randy said as well, that EIGRP has gone away. It hasn't gone away in our environments, unfortunately.
So we have about a minute left for the whole slot and Q&As, and what is left? 1 minute.
1 minute. Yeah, please go ahead.
Tony P. Juniper. Tony P. Juniper. So I do not think that this is that much disconnected on a meta plane, because you'll be facing two problems that kind of the hyperscalers and the modern corporate enterprises that had the luxury to start in the last 5 or 10 years
Yes.
solved in a different way, right? The one problem that you're facing, that scaling the IT staff, right, continuing on this trajectory will probably not be feasible. So you have to ask yourself, how will I reduce IT staff? Which leads you to your automation question and, in a sense, a more regular consumable. That's why they're building fabrics, right? This stuff is regular. It is easier to manage. The second one is, what is the trajectory in terms of consumption of bandwidth that you're seeing, right? Because ultimately, those are components. You consume CPUs as components. You consume memory as components, right? You consume storage as components. You are not running any more punch cards and no tapes anymore, right? Same thing is happening to bandwidth. Well, bandwidth is a more abstract consumable, right? It's much more perishable, but it is a consumable, which if you want to consume it in high qualities at low price points, has to become a component, right? And the whole data center routing, the building the fabrics in meta terms, is nothing else but trying to make networking, which resisted for a very long time, bandwidth consumption, basically a component, right? And that's why I think this BOF is driving, that's where the world is going, right? And the bandwidth has to be packaged into something you buy at Fry's, which it is not today, right? So if you're on this trajectory, it will push you into this direction, because this is how it is being packaged as a component, right? The way the world is going. So all this stuff that you have today will go to more and more regular pattern to reduce IT staff and basically allow for cheaper consumption at larger scales. So this is very valuable. This is also the world that we have to move forward, because as you say, a table of people represents 10% of the GDP, right? And not for the last 10 years, and it will not go away. Okay.
Okay, we need to conclude, actually, otherwise you're going to be eating in your own time, Tony.
You make a lot of very good points, and we're not as different as maybe I'm making it out. And I'll agree with what Randy said. I like that slide 7 on the previous presentation as well. So we do have a lot more in common than maybe I'm letting on. So we do look forward to working with you if you can continue to tolerate us.
Okay, we need to break it, guys. Otherwise, we're gonna go over the agenda.
I'll say one thing. We're really slow though.
Okay, thank you.
Thank you, everybody.
May I ask a question?
Thank you guys so much.
This is Linda Dunbar.
So actually, we have closed the lines. Otherwise, we're really gonna,
okay.
So sorry.
There'll be more opportunity in the next sections. So thank you very much. So what we want to do is we're going to try to be very definitive. We're going to ask a few questions now after this first section, and we'll do. So sorry, you can't hear me. We're going to ask questions after each section to try to do a bit of a wrap up to get a sense of the room. We're going to use show of hands here. Again, we're not voting for any leader here. We're just trying to get a sense of how people feel in the room. So we're going to ask 3 questions, and it's either you're going to feel yes or kind of yes or no position on that. So the first one is, and we added this to our deck recently. So do you feel that there are requirements? So raise your hand if you do feel that there's requirements that are not yet captured from what we discussed today that should be within the focus of DC routing work, potential DC routing work. So if you feel that yes, there are requirements that we have not yet discussed, but they should be considered within DC routing, potential routing work, would you mind raising your hand? So, seem about 20, 30. Okay, so a few hands. Now, if you feel that this pretty much captures it all and there's really not a lot of additional requirements that would really go into potential DC routing work, you can now raise your hand. A little less? Okay, a few hands. Okay, so I guess a few of us still, okay, that's fair enough. Yeah, sorry, second question. Do you agree that the DC, like, there's enough augmentation in some of the requirements that we've seen here that make it different from traditional routing or work we've done in the past? So the question here is, do we feel that from what we've seen and these requirements, that there's enough augmentation to what the demands of the new DC routing environments, that we think there's a lot of augmentation from what we used to do? So is there enough differences here that we've been exposed to that we feel that it's quite different than traditional work we've done or traditional networks we built or data centers we built? Okay, so show of hands if you do feel there's a significant difference. Okay, a few hands. And if you feel that, no, there's not a significant difference from what we've done historically. Yeah, so nothing changes. So if you feel nothing's really changed and we're just more of the same, please show of hands. Okay. Sorry, you can't hear. So
this
only a
Linda,
couple
I have
hands.
a question. I have a comment on this. You are asking from the requirement presentation from those two people's presentation. Is there any differences? I would say that it's not because of they presented. It's actual data center today is different than the like service provider network. And data center then has specific characteristics, and I haven't seen that being presented because the topology is very simple and very kind of different than the traditional ones. I think there's significant differences.
Yeah, understand. So again, unfortunately, you're correct. You are 100% correct. And we agree. We didn't see all the potential requirements that could possibly go into this. We could only cover so and so much. We took some initial data. And that's why I tried to ask a question up front. Are there additional requirements that were not yet described here that would go into it?
I would not call that requirement, as the lady earlier saying. This is not really a requirement. I would say it's more like characteristics of the data center networking. Like, for example, it's actually maybe less. Maybe you need to remove some of the routing things we needed before. It's kind of trimmed down, removing features, not adding features. That's my point.
Yeah, it's, you probably, I think you're right. In some perspective, we need to remove certain functionality, but at the same time, you probably need to add functionality to, compensate for like the new, the changed kind of, routing environment. So by the way, this is not like a Q&A kind of, we're just trying to, feel the sense of the room, because otherwise we're going to be running totally out of time. Okay, so no comments, just hand raising basically.
And last positional question, based on what we've seen so far, do the DC routing requirements drive it? Do you think that this would drive us to new protocol work, just from what we've seen so far? And it's a show of hands. Yes. So if yes, please show of hands. About 20. Okay. Yeah. Sorry, repeat the question. Repeat the question? Is that what you're asking? Okay, so the question was, do we feel, from what we've seen from the DC routing requirements or characteristics that we've seen exposed to us, that this drives us to do potential protocol work? So I'm repeating the question. So you're asking, it's the same question I just asked a second ago. I apologize.
Can I just make a comment?
Let me just finish the question, please, if you don't mind. Okay, and so if the answer is no, you don't feel this drives us to new protocol work, based on what we've seen, please show of hands. About 10 or so. Okay. Okay. So just to wrap up, and then if you want to ask a quick question. So it seems like from that last question, more people believe that, yes, this seems to indicate that potential new protocol work might be needed to help address some of these characteristics. And I'll use the word characteristics. Maybe that's a better term to use at this point versus a hard set of requirements. Do you have a very short question?
A quick comment. Jan Flieren, Bloomberg LP. From the comment that I had was that there's definitely a need for possibly more protocol work. but does it absolutely, and there's definitely need to be developing more things for fabric-like implementations that are distinct from, let's say, how traditional data centers got built. But does it really have to be, I mean, I could see how this could be called, fabric, but does it absolutely need to be called DC routing? There has to be a middle ground to this, but the different things that I see many of the people here are discussing are not necessarily specific to pure, data centers.
So just to comment, that you're correct. The DC routing was the name of the BOF, and we were just trying to get input. This is a non-working group forming BOF, and there's no specific indication that we're going to have a DC routing working group per se. This is just trying to get input from the group and community.
So just to share personal experience, so besides my routing life, there's
make it short, okay?
There's another type of life relevant to mobile edge computing, some others. And I think what we are doing here is going to be very relevant to extending routing to the edge with all the new IoT endpoints, with everything that's happening in the radio, and 5G. So naming, I agree with you, it will evolve.
Okay, so now we're going to move into another section of the BOF where we're going to specifically dive into a couple of proposals that were put out there that have been circulating, and we're going to capture some of that potential work here.
So we have a clicker thing here. So in the agenda, you had 35 minutes. Now you have 25.
That's good enough. Thanks. Morning, folks. I'm going to talk about BGP-based SPF extension. This is the work that I did with my fellow co-authors from Cisco, Nokia, and LinkedIn. So the main problem we were trying to target was, again, massively scalable data centers. They've implemented some sort of layer 3 routing. This has been done today. There has been some kind of centralized route control using a controller-based solution. No surprises there. And from operational simplicity, most of these folks have deployed BGP as their routing protocol. The route controllers we talk about have a very similar functionality like a route reflector in sense that they may reflect routes, and it acts as a central database for policy enforcement or any kind of management that you would need to do. Typically, the route reflectors that are used inside BGP that are not in forwarding path or assumes a presence of an IGP-like protocol to resolve the next stops, the underneath next stops for BGP. In MSDCs or typically class networks, this problem is resolved by having hop-by-hop sessions set up, and therefore the next hops are just recursing over a directly connected interfaces. So the solution that is proposed here helps a deployment of a controller type class model where you could still use BGP and get more convergence from BGP by avoiding head of line blocking that you would have to otherwise incur using a distance vector protocol. Here are the standard advantages of running BGP or SPF, over any distance vector protocol. Nodes have a complete view of topology. Therefore, it's an ideal sort of an algorithm that you want to run as an underlay protocol. Only network failures need to be advertised when you have a link failure or a node failure, and that results into typically a faster convergence and better scaling. Lastly, SPF also gives you a much more optimal shortest path routing as well. Then you look at the advantages of BGP. Here are the following advantages. It's a robust and a far more scalable protocol, has a wide acceptance, has a pretty good reliable transport over TCP. It guarantees in-order delivery, has incremental updates. There's no flooding in there. And lastly, it allows you to work over multiple different peering models. So with that in mind, if you were to combine both link state as well as BGP together, here are the changes you would probably need to make to the protocol. You want to define a new SAFI, so you carry this over a completely different address family. We have done that. We have defined a SAFI that mimics pretty much a link state SAFI that has already been defined inside BGP. And the reason to do that is that the packet formats and link state SAFI very closely mimic the IGP packet formats. You have a new capability that lets you exchange the new SAFI and establish the connection only if it sits on the other end. Supports multiple peering models and essentially runs a Dijkstra instead of distance vector. So when you run a Dijkstra, basically the next hop and the path attributes that are carried to resolve the next hops are kept intact so that you don't break the base RFC 4271. You, however, replace the decision process of BGP, in particular the phase 1 and 2, with SPF. Phase 3 of the decision process can be short-circuited because you're talking about node IDs and prefixes here. And finally, you need to ensure that when you're announcing these updates, only the most recent version of NLRI update is accepted. This is something that BGP already does. You could augment it with sequence numbers on an update message and actually take care of this problem. From an SPF standpoint that is defined in this proposal, it's a fairly simplified SPF that runs with a point-to-point connection, scales very well, could be augmented to support LFS, segment routing SIDs, and other IGP features. Also supports a dual stack for V4 and V6. The part of the work that is not covered here is if it runs for any underlay SAFIs or address families, how do you stitch it with overlay BGP address families? We think this is a matter of local implementation policies that can be taken care of by individual implementations, and therefore it doesn't need to be standardized. Lastly, the changes that I described for SPF can support multiple different peering models, be it a route reflector or a controller-based model. The route reflector could be inline, or a controller could be inline, or it could run somewhere in the cloud and it should still work. And the SPF computation here is fairly distributed. So the controller doesn't have to run any SPF algorithms, or a route reflector doesn't have to run it. And therefore, you would technically avoid any head-of-line blocking that you would have within distance vector, where you run the best path, compute the best path, and then announce it out. This should further help reduce any delays and increase the convergence, if any. So that's all I have. Questions?
Jiahu from Huawei. In fact, I have discussed about this idea with some OTT guys. Some OTT guys who has deployed BGP at IGP for a long time. So their interest to explore this solution, although they believe it should be taken as a long-term solution, but they think it has big potential.
Cool, thanks.
Ankur Dubey, VMware. A question is, in the slides you mentioned that you'll be replacing the phase 1 and phase 2 processes. But BGP provides, the policy is like kind of central to those decision processes, and you should be able to, continue having the capability to apply the policies, at rib and rib out. What are your thoughts there? I mean, why do you say that it's replacing?
So the policies that are applied within BGP, whether they are at an inbound or an outbound, they are typically done either before you run a decision process or after you run decision process. Those policies would still be supported by this protocol, but the best path process that you would run post an application of a policy for inbound processing simply gets replaced with an SPF. So you don't need to run any in-rib evaluation into BGP best path, which is the 10-step best path process. That is what it meant. Does that make sense?
Yeah, sure. Well, phase one and the phase two processes do mention that you apply the ribbon policies. I mean, in the phase one, you do apply the policies before you say that, okay, this route is now selected to apply to, selected for the local rib. And same thing for phase two as well. You do apply the route policies outbound, and those, I believe, are considered as part of the decision process. I mean, the phase processes. So, I mean, it's maybe for clarity, it's good to say that, okay, you are applying the policies that is not affected. So that, that remains clear. And then you can do the SPF calculations and all this stuff, and that's all good.
Absolutely.
Yeah.
Hey, question here, Alankar, Comcast. So we are solving only one part of the problem here, right? It's just the SPF piece. I mean, looking or going through the requirements from 2 or 3 different slides, it's very specific one problem that we are addressing here, right?
That is correct. We are after making a protocol specifically, in this case, BGP, far more optimal in sense that it would help towards increased convergence. If that is what you are alluding to, yes, that is what we are after.
Right. What I'm trying to put in perspective here, I mean, there are many other things that are, we captured as, I won't call it requirements, but as part of the wish list, that we need to solve these, 10, 5 different things. And what we are addressing here is very specific one, which I mean, I agree, we need some kind of SPF sort of thing, right? We need to bring some link state kind of thing in the data center. But what we are solving here is just one part. I mean, out of the 10 things, this represents a very small portion of it.
Yes, and my answer still stands, that we are looking at optimizing the protocol in a way that it helps reduce OpEx of a network by achieving a better convergence and better manageability by introducing a presence of a controller-like model. Yes, there are other problems that are listed out in the requirements, and we can address them. Maybe to address them, you would require a different set of solutions, while this is specifically focused towards solving some of the OpEx issues of the network. So we are in agreement.
Makes sense. Just wanted to echo one of the other things that someone brought up, that we want to solve the problem, but we are looking for more simplification and removing features than adding a lot. I mean, I agree we need enhancements, but it's not like overloading some existing BGP and trying to solve it. I mean, simplification is also a very important piece that's required. And that's my opinion.
AC Lindum, co-author on this riff. Just a couple comments on some of the previous. With regards to the phase 1 and phase 2 BGP normal processing, you really have to modify that for this SAFI if you want to get the same convergence behavior of an IGP. You can't keep it exactly as it is. That's one comment. And the other comment is, I think this of the requirements that are actual routing requirements and not data plane or management or platform requirements that we're in, I think it covers more than just one of them. I mean, the whole thing about auto discovery is a separate topic that you may or may not want to just use the routing protocol to do. I think that's a separate, you could separate it. You can do it with BGP, you could do it with another protocol or whatever.
Fully agree.
Randy Bush, IIJ. We have a long history of things that we design for the local area network goes out to the wide area network and gets in trouble. One of my hats is a researcher. I think I could model this in a data center. I think I haven't had enough coffee to understand if somebody tries this on a large transport backbone, and I don't think I want to have that much coffee. So I think this has the limited, for the moment, I can put up with this on the limited scope of a data center. And I think it scales well for that. And it relies on the homogeneity and so on and so forth. So I see that just red flags if people start to either add requirements to make it work on the WAN or try to apply it to the WAN. I think we're stepping over the line there.
Robert Rashuk, Bloomberg. So if you actually are trying to do new SAFI only to signal link and node failure, it appears that you can actually do it today without that new SAFI. You mark a loopback address as the node with a community, pick your own, and the link address with another community, and you can run your SPF in the background without extending protocol. If you really wanted to do something like that today.
Yeah, absolutely. I mean, there are several different ways. The reason to use new SAFI is to make sure that you have a clean solution. And when you're running across multi-vendor implementations, you sort of don't want to make changes that are not seen across on the wire. So a new SAFI pretty much gives you a clean slate to do this. And more specifically, it lets you break the protocol into a different set of implementations or different processes if you want, and scale it out as well if you need.
Right. Just one more comment on that, AC Lindum co-author, is that, right today we're already using BGPLS for other purposes. And we're reusing a lot of those encodings for the link and node attributes. So, if we want to change the behavior like we are to get the faster convergence and use and do a different reception to determine which version of an NRLI we use, we really need a different SAFI to attach this new behavior. We can't just poke it, reuse and put communities, I don't think.
I think what will be also good to have in this draft is, take example topology like, typical leaf spine topology in the data center, because we are trying to do this for the data center, and kind of walk through that. Today, if you have BGP or OSPF, this is how the routing works, and this is how it's going to work with this new proposal, and these are the benefits. So I mean that'll give us like a better understanding of what we are trying to do.
That's an excellent suggestion. We could augment the draft with a section in there describing.
Thank you.
How the behavior would look like.
Speaking as a commenter, Victor Coursing. So as an implementer, one that's focused a lot on using BGP for a number of reasons. One is I see a lot of potential personally, in so much that, a lot of us have gone to try to do holistic BGP deployments for a number of operational reasons. Second item, to what Randy had mentioned, potentially if something like this were to occur, we could put a applicability statement on it to define what is it specifically we want to try to address, and so such that we don't allow something like this to kind of be used for other, or people are aware of what it was tailored to do, as opposed to just some generic tool.
Yeah, sure.
Justin Sirasas, future request to the chairs, rather than trying to compare apples to oranges, it would be great to have all the apple and oranges and other fruit to be compared to a single set of requirements in particular topology. So
I believe that was a comment for you.
Yeah.
Yeah, so I took my chair hat off when I was just speaking as a person who implements data centers.
No further questions? Okay.
Thank you.
Cool. Thank you.
point of order or question in reviewing these to the chairs? May I ask this at this time? I simply wonder, some of the things might address things for the brick and mortar problems and might not address for the other. In presenting these solutions, for example, the last one addresses a problem we've had a long time with IBGP, and it's been the topic of study for a long time, and might indeed help the people in the brick and mortar, whether it's doing everything that is in the final thing that Jeff indicated. What is the scope of the discussion you're hearing? Is this question germane to it? Because it's hard to determine what I'm listening to and what I'm trying to provide input.
Yeah, so I think we mentioned that, during the beginning of the session here, the scope of this BOF is first to get, to come to an agreement of an understanding that routing in the data center, may be a different kind of beast than routing in the one environment. So majority of the routing protocols right now have been developed for the one environment like 15 years ago or something like that. So, in that envisioning, so we first, tackled that by looking into some of the requirements and then come to an agreement that yes, potentially something actually has changed. And that has been then followed up with, some people have realized that they developed like new concepts, new ideas, and that's what we're presenting right now with the BGP SPF. Other people actually have tried to solve this changing, these changing requirements by augmenting existing technology, and that is what is going to be presented after the new protocol. So,
okay, so the problem is there's a third option. Some of the things we've looked at it for a time, like the BGP SPF LSPs, but they didn't really fit what we had. But again, we need more requirements out of the brick and mortar and the rest in order to say, gee, it may not fit the layer characteristics, but it might really help data centers in the brick and mortar to really do a much better job. So I would ask you if you would maybe make a third category, because I think it would be helpful to some of these people.
If I may comment. So we are not trying to choose a king, and it doesn't have to be single thing for everybody. If your IT staff is happy with OSPF, maybe just reducing flooding or optimizing it would be good enough. So mileage varies per company, per type of IT staff. So it's important, again, to make people aware there are different solutions, and it is good to provide guidance for implementers, for designers, to what it should be, what people are looking for.
Randy Bush, IIJ. It would be good if we didn't try to boil the ocean. I know it's a tradition to do so in the IETF, but having a narrow focus on a nice, I love the fact of that slide 7 was great, and excuse the drift, but David Siqueiros, a very famous Mexican painter of a previous century who did ceilings in churches, among other things, he has one of the man who was so open-minded that his brains fell out. I don't think we need to do that here.
Thank you. No, you have a clicker thing. You have about 30 minutes.
All right, how do I get this thing up? You guys hear me? Yeah, okay, that's constraining. Good morning. Yep, whatever time zone we're in. So I'll be showing something radically different. I got interested in the specific IP fabric problem 10 years ago. Well, it wasn't IP fabric, because Mac was like the hottest thing. And work with people, along those BGP angles, looked at ISIS modifications, been around all these things for quite a long time. And these requirements were emerging. I was talking to a lot of people, and what I observed is that the most interesting angle in this IP fabric development is that we have a chance to build a component. We have a chance to build a RAM chip. Yes, we are IETF, and we networking are used to OPEX, right? We were driving insane sizes of IT departments in corporations. And that can be done, right? We can continue on this IP fabric along those lines, right? And hyperscalers are showing that OPEX is free. Well, reality for the majority of people is not that, right? A very interesting angle is to get the IT departments down and make bandwidth, networking, a consumable, like you go to Fry's and buy a RAM chip. And no one does a CAS configuration on RAM chips. So basically my angle is that I was looking as the most important requirement for a good IP fabric, data center fabric solution would be something that would have a zero OPEX, right? So you pay your CapEx, and you pay your CapEx as you go get more bandwidth, and you don't have to scale your OPEX. Train people, configure stuff, build controllers, do all these things. So what it boils down to is that this thing is not working. Okay, it is. So the requirements draft is a good wash list, right? Like lots of good governments have been made, like 512 is not really the reality, 512 ECMP reality for most people. But if we do the job well, it will. How much memory do you have in PC? The memory has been done well as a component. Look how many core, what capacity you're running, how many CPUs you're running, how many solid state, how much storage are you buying compared to what you were buying 10 years ago? And it isn't because the solid state disks are so bloody complicated to run like punch cards. One of the main reasons is that that stuff became a component and the volumes were driven down and the prices came down. Volumes up, prices down, called the McKinsey curve. So how could we take something like an IP fabric there and make a bandwidth, an easily consumable component for corporations, whatever, right? Whoever needs bandwidth can consume it very easily. So the watch list is pretty good, but there's more stuff that needs to be met for it. And that's kind of the additional things that Rift does on top. And I'll not be talking, if you expect protocol formats and understand how the protocol is put together in egregious detail, there's a draft, there's more authors on it, and so on. I'm giving here more of a pitch, why it would make sense to do something radically new, and why the stuff just incrementally progressing with what we have will not bring us into a new landscape. All right, so the most prevailing thing is that we need a zero config, ZTP. You just punch those things in, just like you punch in RAM chips. Buy more switches, buy more links, and you're done. So there's two flavors to that. You can assume that people miss cable. That leads you into a different area where you need some minimum configuration, or you can assume that people cable correctly, which leads you to a complete zero provisioning solution. And the drafts that I put out doesn't have it yet. We have it solved. So the next revision will talk about that. So we can really make an IP fabric zero config. You just buy more switches and you cable them up. The next one is an interesting observation that if you look at the data center fabrics, the main volumes are TORs and servers. And those cannot hold large FIPS. Right? The FIPS have to be small. So on the TORs, you really want D4 routes, because that allows you to run a really cheap silicon. The next one is that we will be going to high degree of ECMP, because otherwise you have to build very deep fabrics and the delay starts to go up. So the way I see the economics and the delay requirements will force us into a high fan-out. So I think a solution where we have to address fairly high fan-outs is necessary. There seems to be the prevalent thinking is still that we will need some kind of a traffic engineering on the fabric. So get these flows around in different ways depending on load and so on. So Rift addresses that. I do not think long-term that will prevail. We do not optimize 17 different types of RAM and 14 types of storage. Okay, we just have a lot of it, and we make sure that we can saturate all of the stuff that we buy. And I think that's where the IP fabrics will be going. We're talking IP fabric. We're not talking WAN, right? The problem changed. When you are restricted by geography, expensive bandwidth, a lot of optimization problems. Here we are talking locality, where I can put this thing in a highly structured way together, predictable way together, and just buy very cheaply and quickly a lot of it and provision it, if it is zero-touch provisioning. We nevertheless have to see the whole fabric. Fabrics will not become, well, we have in RAM chips ECC. I think the fabric will still need more. So I need some kind of observation what's happening inside the fabric. Where do I have losses, what fails? So we have to address the requirement that you see the whole fabric at a certain point. Zorif does that as well. The carrying the opaque configuration, I skip over that. I think that is very valuable. The taking out of production quickly, I think, is a real problem. Switches will need to be taken in and taken out and put into the fabric relatively quickly. And during this time, you cannot afford black holing. Okay, so I think that being able to take something within milliseconds out of production and put a new one in is an important requirement. The automatic disaggregation falls out from the other requirement where you really want your TORs to be cheap. If your TORs have to hold large FIPS, the silicon will be expensive. And there will be a lot of sloshing information, which will lead to convergence problems, all kinds of anomalies. But once you aggregate and links fail or node fails, you have to deaggregate. So that has been well explained in the RFC 7398, don't remember the number. And what is very beneficial is if you keep a minimal blast radius. So what do I mean by that? If you grow these fabrics and you end up with a solution where adding a virtual machine or a link failing shakes the whole fabric, you'll be inherently limited in scale and stability of this thing. And it has to do with multiple facts, like how much information does a node have to hold? How much information do you have to exchange to converge the whole thing so everybody has the information necessary? And the fluctuations on the fabrics are actually quite phenomenal. Just on large fabrics, just rolling updates of servers are generating quite a significant amount of routing churn. And I think it will only get worse because it is a consumable. Okay, so people will just do whatever they do without thinking what stress it puts on the underlying infrastructure. Fabric should become an infrastructure. So those are kind of the additional requirements, what I see when you drive the whole thing towards the zero OPEX, and why I think it justifies a completely new protocol, or rather, this set of requirements to get you such a low OPEX fabric is not possible to meet with the extension of the traditional protocols, which I helped to invent and love and made a good living for a long time. All right, so what I show you is quickly general concept, because the concept is radically different from the routing we did so far. I show you an example how an automatic disaggregation would work, which on traditional routing, so far no one addressed, and I think will be very difficult to address. I'll talk about small detail about horizontal links to show you how different the whole thing is working. And then I give you a couple of more things that fall out elegantly out of it. Yes, but it's so new. So either we stick to the shore and sail along, and a lot of people may be comfortable that way, or we leave the shore. And that's the only way to discover a new ocean. And that has been done before. We were in ATM in frame relays, and things have been done certain ways, and that was the only way to do things. We're in a different place because certain people questioned circuit switching, which was considered completely crazy initially, by the way. And of course, I must be crazy, but I'm an unreasonable man. If I would be a reasonable man, I would try to adopt to the realities as they are. I try to change reality. Having said that, what's the concept that falls out? And it all falls out from pretty deep thinking, a lot of math and so on, but that is irrelevant, right? The product is, the consumable is this. So when you look at the fabric, what strikes you is why is it so different is the regular pattern is enticing, but the fundamental change compared to what we are running today as routing, as generic routing, is that we have a sense of direction. So it is a ordered lattice, whatever that means. So assuming this compass direction. We know what is north and what is south. And with that, of course, we know what is east and west, which is interchangeable, but it's a different thing. We can kind of assume some kind of numbering of the levels. So let's just assume the leaves are level 0, and then we go level 1, level 2, recursive. So having this sense of direction at the head and the tail, the first concept that we apply is that we have this topological sort. That's really what it means. It's the sense of direction. We put the concept of link state flooding going up only. So the leaves propagate up and everybody propagates up. So the guys at the top have basically the whole topological information and can compute trees. And that is actually necessary because once your traffic hits the superspine, you must know which way to go. You have to choose whether it's left or right. You can't just, the buck stops there, right? Everybody passes the buck up, but the buck stops up with someone. And that, worst case, is the superspine. On the other hand, when we're going down, we can just use distance vector routing. And in most extreme case, just propagate D4 routes. Just initiate D4 routes. So the TORs at the very bottom end up simply with D4 routing. They end up with a D4 route which has a high degree of ECMP. And if we take this concept farther, we can take it all the way to the server, which becomes quite interesting. And if you think that we can pull it down to the server, the requirements, the lower you are in the fabric, the easier it gets. You basically just do D4 routing, ECMP D4 routing. So that's the concept, how it's put together. Now, the last requirement is not the last concept that you have to add is that not that obvious. The closed fabrics, which is what is mostly used, do not have horizontal links. And that's to do a lot with blocking probabilities, and your fabric starts to behave funky if you do that. You can do that, but you run certain risks. So you want the nodes at the same levels to see each other. And since they just propagate distance vector down, and you only float up north, the red nodes would not see each other. So to make them being aware of each other and the links, the state of the links, we have to bounce off the lower layer. And it's completely recursive again. So every layer bounces the upper layer's node information up. So the red nodes are aware of each other. The leaves are not aware of each other. There's no need. Now, why would that be? So one example. So once we aggregated everything up and links fail, we could black hole very easily. And that's one of the examples. So that's showing a hyperplane slightly flipped problem, not very relevant. So what we're having here are a hyperplane of two red nodes at the top and green aggregation switches and the blue leaves. And if you look to the left, that you see that all the D4 routes get distributed all the way down to the leaves. From the right side, from another plot, we have a prefix, a P1, that is being advertised, flooded up, right? All the flooding goes up, so the red nodes can compute down into P1. Unless the orange link fails, or worse, was never there. So imagine what the routing would look like. The leaves from the left have just D4 routing, so they just pump the traffic up. So if they pump it to the left green node, everything is fine. So I blanked out the other hyperplane through the other green switch. So let's not even consider that. And the green switch has D4 routes again to the red spines. So it would just try randomly load balance the traffic, which all works fine if the fabric behaves correctly or is, in perfect state. But if the orange link fails and you try to go to P1 through the top red node, you will black hole. So you need some kind of disaggregation to prevent black holing. Now, if you run this kind of protocol, and we remember the red nodes see each other because there's a reflection of the green layer, the lower red node can, after the SPF computation, understand very easily that the P1 cannot be reached by the upper node, because the only possible next hop is the green switch on the right, and it has no adjacency to it. And the reaction is very simple. You just disaggregate the P1 in the lower red node. So you don't only advertise the D4 route, but also P1. That does not propagate to all the way to the bottom, to the leaves. Observe, it just propagates to the green layer. So the very left green switch will have a forwarding table D4 route over those two red, but the P1 only through the lower. And the longest prefix match will take care of itself. It takes a while to sink in because it's so novel, but it works like a charm. So what you get is a maximum aggregation to make sure that all your blast radius are minimum, that the leaf switches just hold D4 routes, and on failures, the algorithms, which are not running in any kind of synchronous fashion, observe, those are fully distributed asynchronous algorithms, will take care of healing the fabric for you. Just like a solid state disk just relocates a factor if it failed, which is exactly what you expect. You don't want to reassign sectors on the disk when it failed, as it used to be the case, as far as I remember on magnetic, which wasn't a lot of fun. As another example, we can talk quickly about what the disaggregation does on the horizontal links. So observe what happens in a topology like this AB, 1, 2, and Z, where the link between 1 and Z would fail. Okay? So the B would get disaggregated on the second switch, and the horizontal links behave just like the southbound links. So A would see B and go through 2, and if anything goes wrong, 1 will also see B and traverse the horizontal link to go through 2. But the horizontal links are only used in failure cases. Okay, because the D4 route will not be propagated over horizontal links normally. We have also addition that for the leaf nodes, and that's what people do is, if you run a horizontal link, it is used as a leaf-to-leaf shortcut. So nothing will traverse it, but you can shortcut to servers if you have very fat flows. So that was just a small smattering, especially the disaggregation is very novel and only made possible by those concepts. What falls out on top when you run this kind of very novel approach to routing is that we can solve a lot of stuff which has been worked on for a long time and cannot be addressed with traditional routing. And one of them is, for example, automatic flood reduction, which is a significant problem if you go very wide in terms of fan-outs on IGPs. So once you start to flood of a couple hundred adjacencies and you try to implement it, you understand the implications of that. So you can use the fact that you have such a dense connectivity to load balance flooding. But normally that has been done through OPEX. So people configured special flooding meshes and to trees, and they made sure that they don't overlap and so on. This protocol can run automatic flooding reduction and flood balancing, just like EVPN active-active. So I'm not drilling into detail because then we'll be here for the whole day. Like I said, the leaf-to-leaf bidirectional shortcuts are allowed. We do have a flooded DV overlay, which allows policies and can be used for something like traffic engineering. Okay, so the requirement is solved. Like I said, whether it will be used, we'll see. The packet formats have been pushed towards being completely model-based. Okay, so that was not feasible performance-wise until fairly recently. It does not, at this point in time, pose a significant roadblock. It can be done at very high performance. The advantage of it is that we come off of very unorthogonal packet encodings, which have been optimized now over a long tradition in networking for performance. We were always bandwidth restricted, right? Or also CPU restricted in terms of processing. Those restrictions are going away, especially in data centers. We have enough RAM, we have impressive CPUs, we have bandwidth to burn, okay? What we are lacking with the traditional protocols is that the turnarounds to introduce any kind of feature is very, very long. We have a lot of non-orthogonal encodings. We cannot generate code very well. Everybody's writing the node parser with their own set of bugs, and we go through those refs, which frustrates a lot of these data center guys who see the fabric like a CPU. That's just something that there should be enough of it, and it shouldn't get into my way. I don't want to deal with routing bugs that crash my box. So that's one of the way to innovate the protocol much faster at a much lower risk, because you're on a model. So the code is largely generated, and it's much harder to build non-orthogonal models. You can, but it sticks out much more. The channel delivery is actually Rift is agnostic. So the initial discovery goes over multicast. That's really still the simplest way, because you don't have to configure anything, right? But once you get to flooding, distributing traffic, the channels really don't matter all that much. We have all these religious battles. You just go hop to hop and you take whatever you want. You can go over UDP, Quick's promising, we can run it over TCP. Each of them has its pluses and minuses. One thing that Drift addresses is that it gives you very wide, what you would consider LSA spaces, right? It is very feasible today to maintain a lot of information elements in IGP, which earlier was a restriction. And there BGP had a leg up. One prefix change, you send one update. Rift gives you the possibility to generate an LSA per prefix. It's an implementation thing. And the spaces are wide enough, the identifier spaces, that you can very easily come up with implementations like that and basically have the efficiency of BGP, or actually significantly better. Because if you think that you maintain 500 TCP sessions and you flood this change over these 500 sessions out, unless you play some reduction game, you have to generate 500 updates for 500 peers. And even if you're really smart and you generate the update once, you are cranking TCP 500 times. If you go over UDP, this is much, much cheaper, right? You don't have 500 TCP state machines trying to get the work done. You just push this thing over UDP out there. Purging has been completely taken out. That's a smaller detail. And we have a key value store support, which means you can push during convergence time certain things which are important for you over the fabric. And one of them is, for example, service configuration. When you run an overlay, you want a very quick service configuration. You don't want to convert your reachability, which is really nothing. It's like your PC booted. Now what? Unless I ran an application, well, cool, I got the login. So if we put a key value store support to allow, for example, service configuration into the reachability protocol, the moment you reachably converged, your basic service set converged. So it's like your Mac booting. Your Mac doesn't boot into, well, it boots into login. You need to get in. But once you log in, all your windows pop up. All your applications are up there, because the empty desktop doesn't do any work for you. You have a working set. So we can we give people a possibility to very easily to put the working set onto the reachability protocol. So when they bring up the fabric, the services are up as one possible application. Now good, so summary. We have a limited time here. So when you look at Drift and you give it the thought necessary, if you're interested in the technology, you find that you get advantages of both of distance vector and link state. Because the vexing thing is the data center fabric, if you want to really drive it zero OPEX, is neither. So you get the fastest possible convergence, because everything is being flooded. You get automatic detection of topology, which is really a precondition for ZTP, unless you run a controller and you believe a controller is a ZTP solution, which I don't. You get the minimal route on TORs, which allows you, and actually the solution gets simpler and simpler the more you go towards the server. The server is a very simple implementation, so you can pull it all the way down to the server. So that allows you to run cheaper and cheaper silicon at the bottom, where you have more and more of the stuff, right? That supports very easily a very high degree of ECMP, because it's where the ECMP kicks in, it's a link state, where distance vector is not very good at ECMPing. It can do it, but it's a little bit of a crutch. We can get very fast decommissioning of nodes out of the fabric because of overload bits on IGP. It's the same mechanism. And we have a maximum propagation speed, because we don't wait until we decide something like in a distance vector protocol, right? It's a link state. So you just propagate the information, you blast it at maximum speed out. And because we have this flexible number of prefixes, we can get to BGP efficiency in terms of a prefix per update element, if we want to run it that way. But we do not face the disadvantages of both in the fabric. So the flooding is normally what limits the IGP at certain point in time, performance-wise. This can reduce flooding automatically. So load balance flooding, sorry. And we have automatic neighbor detection, which of course can be added to BGP. I mean, any protocol can be modded to the point where it looks like another protocol, right? It's not software is software. Just write enough of it, it looks like, just like something else. And it brings some advantages, again, driven all towards zero OPEX, which the other protocols will have a very hard time to address unless we get to the point where they start to deal with the concept of north and south. This is really like the deciding piece. Do you build a protocol that understands the direction of the fabric or don't you? So it does the automatic disaggregation on failures. The key value store is another act. Forget the horizontal links. The minimal blast radius. If you think through the protocol, it scales extremely well because adding more leaves does not push any load on any other leaves or other pods. It only adds at the very top information, okay? And when something fails, the distribution radius of the change is very, very limited. And what also falls out of the protocol, and that's very non-intuitive, the protocol cannot loop. There are no loops here. The packet goes up until it turns down, and then it goes down, which allows you something very interesting. It allows you to run a completely different class of path algorithms rather than just the shortest path, which we all love and try to stick to. So Rift can actually saturate all the feasible paths through the fabric, minimum hop paths. And it's up to you to decide how you use the weights. You can just blast it through all the feasible paths, or you can just take the shortest one, or shortest, second shortest, and so on. More than bits over PowerPoint? Yes, lots of real work has been done. So this is not just shot out there. If you're interested further to participate, look at the stuff, have a chat with me, we'll take it from there. And thanks for your attention. And Dean is already standing in a very threatening pose.
No. So actually, before we go to the
lower to the microphone.
Hello. So we have about like 5 minutes for Q&As, but before we go there, anywhere the blue sheets? Who has the blue sheets? Nobody has the blue sheets. Okay. Yeah, go ahead, please.
Dan Bogdanovic. So I don't understand the automatic flooding reduction, and I'm trying to.
Yeah, because I took out this one slide, simply not enough time. See me in the bar. We're talking through.
Yeah. So and that is one part for me to be able to follow. The other part is this is sort of the basic. But it's a very stupid thing, but your name is already taken by a company in Boston, and you should really think about renaming it because they have trademark on that.
My last name?
Rift.
So there was only the grow work, which expired long time ago. So point me to who took the stuff as a trademark. Okay, I did a search. I didn't see that.
Oh, it's Rift.io. So.
Okay.
Robert Rashuk. So, Tony, I have one question here. I think you have very good control plane worked out perfectly well. But the problem is with the failure. The failure is addressed by the aggregation, right? You inject the P1 down from the spine to leaves and you fix the problem. But doing that, it's actually convergence problem because it takes hundreds of milliseconds before you advertise the route in any protocol today, going to RE and from RE. So I think it's way too slow to actually be, production quality solution.
So, I mean, Rift can run without aggregation. So that's one of you think, but you pay a tremendous penalty on the TORs and so on. So that's one simple answer. The second answer, go see me to look how fast it can go. And that's why we need BFD. We can get it around FRR times without FRR.
I'm looking for something like LFA addition to that. If you can do it, but technically you cannot, right? Because you don't have information ahead of time.
So that goes down to how fast do we have to converge, right? If people are really looking like in wide area, they go, I want on my data center fabric to have something which is 30 milli, 10 milli. We may get pushed into LFA, FRR kind of things. No discussion. I don't think there's a way around that. But then the whole solution will become more expensive and more complex. If people can live with something like 250 milli single failure convergence, very comfortable with that. Okay, and I found that this requirement is very squishy depending how people build their service architecture on top. Okay, some people are very comfortable with like 1 second blips. Some people are very uncomfortable with 100 millisecond blips. We both know that, right? So that's, can FRR be strapped onto that stuff LFA? Yeah, very easily. But that's of course significant addition in terms of complexity.
No, I agree with your answer, but it was just an observation to state.
Yeah, we wildly agree, right? If you aggregate, you basically do a controlled line. So if you have to unravel the lie, it will take some time. And if you go through a control plane, there's certain limitations, which today with good implementation, it can take you in hundreds millisecond range. But if you look 30, 40, 50, well, that's why we did all the BFT, LFA, and all the chip vendors are doing all the crazy stuff. So, I mean, I can't change the speed of light, and we can only push electrons about 5 gigahertz. I mean, next thing, see me when entanglement is possible, right?
Okay. Okay, so we can actually take the questions from the two people still on the mic, but then we're going to close the line.
So, to clarify, the requirement draft specifically had requirement with support for BFD and none for LFA. In regular topologies, you don't want LFA. Your links are per definition loop-free. What you want is fast rehash in hardware. So support for LFA, from my perspective,
yes. So yeah. So that's excellent observation.
Complexity
yes.
blocks, you don't want this.
The real game is really that if your hardware kicks in and does the BFT correctly and the fast rehashing, a lot of these problems go away. But then, of course, we talk very close to the chip level, right?
Okay, Saikat Ray, Google. Are you assuming that the control plane runs on the switches? What if the controller is completely off, running on some other server?
No, I'm assuming the stuff runs on the switches. Does it? So for the controller side, it has two flavors. One is the distance vector overlay, where you can actually go and push prefixes and policies onto these things, and they will be preferred onto the shortest path. But when it comes simply to the shortest path convergence, I assume that the stuff is distributed for simple reason that it will be always faster than anything you can push from a controller. All right, unless there is some absolutely impossible magic involved.
Gaurav Cisco Systems. It may be worthwhile, because we are talking about different solutions over here, to compare them after implementing them to see which one converge better in a particular topology.
Yes, so I can give you a simple number, like that converges 3 times faster than a host-based IGP, both well implemented. So that's, you get about 3x convergence speed up over a reasonable like 3-layer fabric, you know. So this is a number I have, and I dealt long enough with BGP to know that, well, I'm not here in a beauty contest, and I don't think the convergence speed is really like the highest requirement. What I found for the people I'm interested in who are willing to pay for solutions, the zero OPEX is really the most interesting requirements. People where OPEX is free are very insensitive to a lot of requirements. They have very drastically different ideas, I found. Right.
I mean, convergence is one of the requirement. I'm saying just compare the solutions on all the DC requirements which we have listed over here.
I couldn't parse that.
Okay. Yeah, okay.
It's Alankar Comcast. Just
So
wanted
actually
to comment
sorry,
on...
the lines were closed. We need to move forward. I mentioned the 2 last people were, on the mic. Sorry.
So we can address that question. If you have additional questions, we can address it in the list then, the DC routing list, please. Okay, so thank you, Tony.
All right.
So one simple question. So this was the second section of the BOF. So one simple question for the group. So with a show of hands, this is from a positive side. So we're going to ask one question. Would you agree that the proposed solutions is a logical OR, by the way? Do you agree that proposed solutions address unique challenges in the DC routing fabric space? So from what you saw, these last 2 proposals, would you agree that they address unique challenges in DC routing space? Show of hands. It's about 40, 50. Yeah. Okay, perfect. Thank you. Okay, so the next set of speakers. So this is the review of work that's going on in existing working groups.
So we have in total model of only 5 minutes with Q&A.
Naiming Shen, Cisco Systems, and this is the work I co-authored with Les and Sanjay. So since we are talking about the routing in the data center, and this proposal utilized all the routing features has been developed in the last 25 years. Plus, it supports full routing entries for quite a large size of the DC network, and it can also serve as the underlay routing for the DC. And this proposal is an auto-tier discovery to support the ZTP requirements. And this minimizes the link state IGP flooding problem due to the DC spine leaf topology. And this proposal also handles link and note down events to avoid black hole. So there is one new TRV is proposed for this proposal, and the T bit is to indicate which tier level the node is at. And the tier in the current proposal is from 0 to 15, with 15 as an undefined level. And the L bit indicates this is a leaf on the adjacency. The R bit is for the spine to indicate you can use this adjacency as the default gateway. And there are 2 optional sub-tier redefined for the black hole avoidance. So in a very basic example, here we have 2 tiers, and at the bottom layer it's the leaf, and the top one is the spine. And the leaf node will set the tier level to 0, set the L bit, and flood its own LSP towards the spine. And the spine will in turn in the hello set the R bit for the leaf to use itself as the default gateway, and it will not flood the LSP back to the leaf nodes. So the spine nodes has the full I-size topology database, but the leaf nodes just point default towards the spine. So it supports the multi-tier level. This is the auto-tier discovery. And by this, we mean the tier 0 is defined. As long as the tier 0 defined, all the other tiers are dynamically run by exchange the packets and learn its own position. So you can see the tier 0 is the leaf to the tier 1, and the tier 1 can in turn be the leaf of the tier 2 nodes. So in this particular case, on the lower right, the L6 will only flood its own LSP L6 towards the S3, S4, which is the tier 1 nodes. And for example, the S4 in the tier 1 will flood L4, L5, L6 plus its own S4 towards the C1 and the C2 of the tier 2. So this is the last slide, and talk about how to handle the link down events to avoid the black hole. So in this particular case, talking about the convergence, actually this requirement is only an optimization, because if you think about this, S3 to S6, the link is down. And even if the L4 is sending a packet to S3 to reach the L6, the S3 by BFD or some other mechanism immediately know that it cannot forward to S6. It can forward uplink to the C1 or C2. So in the long run, you don't want to do this because it increases the packet latency. But in a short term, what we can have to do is you forward towards the upper layer, and the upper layer had the full topology of the bottom layer. So that convergence can be actually solved in this particular case. But in the long term, we don't want to do this. So this introduced the negative routing between the tiers, and the negative routing is only necessary during the tier 0 and the tier 1. So that's all my presentation for this proposal. Thank you.
Cool. Thank you. So we have time for one question if there would be one. If not, then that is okay also. Okay. We have 5 minutes, including Q&A.
I'm Russ White with the Blue Screen Company. No. Russ White, LinkedIn. This is ISI support for Open Fabric. This is the, if you haven't noticed, the section 3 of this agenda is actually the humble section. We're not inventing new protocols and doing weird things. We're just making simple things. Another thing I'll point out is that this draft is compatible with or complementary to the other 2 drafts in this section, which are naming and Cisco and those guys. We're actually working together to make sure that our drafts use compatible signaling and things like this. So we're just 2 different kinds of things on the same thing. So the idea here is that with Open Fabric is that we really want to just simplify things. We see a lot of complexity in the data center fabrics. LinkedIn runs a pretty big data center fabric, a bunch of pretty big data center fabrics. We just want something really simple to do to give us IP reachability and label distribution. And we don't want all the policy stuffed into it that BGP gives us. We don't want anything else. We do want a link state protocol because we want to have full topology of the information. So separate reachability from policy. We want to minimize or eliminate configuration. The way this is set up, there's only one router on the fabric that needs to be configured, and everything else is computed and can come off of servers or configuration systems or whatever you want to. Link state, we optimize convergence and optimize scale. So what we're going to do to separate complexity from complexity is topology and policy is we use a distributed control plane, like I said, to give us reachability and label distribution. And then we want to have a controller-based overlay using something like PSEP or I2RS or an undefined thing that actually pushes policy to the top of rack switches and uses segment routing to do all TE and other things like this. So that's kind of the thing that we're doing here. The goal on the distributed protocol is to build the simplest possible distributed link state protocol. We don't want any policy. We don't want any configuration. We want any extra stuff. I don't know about your data centers, but in my data center, one of the problems I have is I have SRE and NetOps guys and NetEng guys who want to go use BGP policies and stuff to play around and make traffic engineering work. And we really shouldn't be doing that because it just creates all sorts of weird stuff. All right, so fabric location is really simple. As long as you have one top of rack switch or T0 configured as a T0 when you boot the fabric, you can compute using the hop count to and from that T0 as defined everything else. You can compute your tier level no matter what your topology is from that one T0. Once the fabric boots and a bunch of other people have computed themselves as T0, the requirement for the single one to be configured goes away. The requirement for a single configured T0 box is only to boot the fabric when you have nothing up to begin with. So you can read this in the draft. It's actually pretty simple, trivial. There's some IPR around it, but it's been released to the IETF and stuff like that. So forwarding optimization, there are 2 stages in forwarding optimization. One is forward optimization or flooding, I'm sorry, flooding optimization. One is forward. So we look at the flooding coming off of a T0 and going towards the spine. There's a particular way that you use neighbors, which by the way, we have experience in from mobile ad hoc networking. These are actually extensions in OSPF that does something very similar to this already in the field deployed and working. So we have experience with this and we know this works in this direction. Nikos, who works for LinkedIn, suggested a reverse optimization, which is just to not flood back down the SPT towards the originator, since you already know what the topology looks like in your LSDB. So this actually quells the back flooding. The way this turns out is, depending on how you have these parameters, you can set parameters for how many neighbors you want to pick, or reflooders, or things like that. Every IS on the fabric, and by the way, this is grounded in IS to IS if you read the draft, only receives 1 or 2 copies of every LSP on the fabric. So once you know your location, we assume you're going to connect to a controller. You're going to get things like DHCP pools if you need them. You're going to get, maybe you'll get your label pools if they're not calculated locally. Things like this. All of this stuff is going to be pulled off of a controller, probably using a pub subsystem or gRPC or something like that to make it very fast and efficient. So that gives you the ability to pull receive status as possible. We are currently working on an initial implementation of this in the ISIS part. We don't have an implementation underway or under tow for a controller yet. We're still working on that, but we actually have an initial implementation under tow in free range routing. So there will be a free range routing implementation of this, hopefully, well, next 3 to 4 months, 5 months, something like that. So further updates to current drafts in the queue. I have a couple more things I need to do. I need to change something about the hello processing to make it a little bit simpler. We've received a lot of help from the community. I'd like to say thanks to everybody who sent a comment on that. There's a huge contributors list. It's been really fantastic getting a lot of people from the community. So that's kind of it for ISI support for Open Fabric. Any questions at the mics? I see nobody is there. Read the draft and make comments and tell us whether it fits your use case or not and what could be changed to make it better. I know we're not going to solve every use case with this draft, and that's okay. It's a pretty simple concept, and we're just trying to do a few things.
Hi, this is Uma from Huawei. Russ, I sent you some comments regarding the multi-topology, the current draft, what you proposed, what you are removing from ISIS. You described related to multi-topology, a lot of things are inconsistent.
Yeah, we remove a lot of stuff from ISIS.
Just have minor adjustment there.
Okay, good. Yeah, that's cool. Yeah, one of the parts of the draft is we have a lot of stuff that we're pulling out of ISO 10589 to make the protocol simpler. We're trying to get down to very small lines of code.
I'll say. So this work is probably, this is probably going to be tackled by the ISAS working group, going forward. So.
Hello, everyone.
So you have 5 minutes, and it's going to be a hard stop, unfortunately.
5 minutes, okay. Let's talk about how to reduce the OSPF ISIS flooding in large-scale data center. The reason that OSPF ISIS is not much suitable in large-scale data center networks is due to its flooding problem. But on the other hand, the beauty of the IGP is it can support a full view of the global topology. That's why many other guys pursue to extend the protocol, such as BGP, SPF. But as I had mentioned, BGP, SPF may be a good candidate for long-term solution. This solution intended to be a very short-term solution because it requires very minor changes to the existing MPS protocols. Since it's the BOF time, I will not discuss many details about this solution. I just show the general idea of this solution. It's a mix of the centralized link state distribution and the distributed SPF calculation. For instance, OSPF ISI routers within class just need to exchange hello packages to fight each other. There's no need for them to further exchange RSAs or RSPs. They only need to exchange RSAs and RSPs with the controller, where the management layer. In fact, the controller is exactly OSPF, DR, or ISS, DIS. So, as you can see from this finger, it's heavily depend on the existing protocol capability. The only requirement is you need a dedicated network, management network, to interconnect the controller and all the routers within cross networks. If you are familiar with Google FirePass, there are many similarities between these two solutions. The differences include, first, this is MPS. This is IETF protocol complaint solution. Second, it doesn't have heavy dependency on the reliability of the management layer. The counterpart in the FirePass is CPN, because this solution has a very simple rollback mechanism. In other words, when a router in the class lost connection to the controller, it can roll back to the traditional IGP mode. That's all. Any comments, suggestions?
All right, thank you. Sir? Yeah, okay, so we're going to ask one question at the end, at this point, and then maybe comments from AD if he wants to share. So the one single question at this point then is noting that contributing to any new solution is not mutually exclusive. So show of hands, who here would be interested in participating and contributing to potential new work in the routing area? Yeah, so about 40, 50? Okay. By the way, I will publish the questions I asked with kind of the reception we got to the list after, just for note. Okay. So, Alvaro, did you have any comments you wanted to share with the BOF? If not, we can open up to general additional questions or comments from the group.
Sure. Hi, Alvaro Retana, I'm the routing AD. So yes, what I was hoping you guys would ask next, and I don't know if you have another question you're going to ask or not.
The one about generalized versus specific?
No, not that one. But so the purpose of the BOF, as you guys said at the very beginning, was to try and see what the landscape is, right? Get some requirements, see what people are doing, and figure out if there is a need for new work. And I think that many people raised their hand and said, yeah, we need maybe new work to be done in the IETF. Now, many of you, I think, also raised your hand saying, yes, we would be willing to work on something new. Now, there were two proposals here of new work. What I think I want to ask extra is to get a sense here in the room of people who would be willing to work on the specific proposals that were put forward. In other words, if we're going to use this BOF to, in the future at some point, maybe get some new work in the IETF, it would be nice to know if you want to work on that solution or not. Does that make sense? Yes? Hum something? Anyone? Raise your hand. Whatever. Okay, good. So the question I'm going to ask is this, two questions. Since we have two proposals, right? Assuming that we go forward with work in those proposals, let's take the BGP SPF proposal because it was presented first. How many of you would be willing to contribute to that work? Meaning, before you raise your hand, you can only raise one hand. Meaning, would you be willing to not only read the drafts, make contributions, do reviews, participate in some kind of effort? The type of effort I don't know, it may be a new working group, it may be something that we roll into our TWG or something else. But how many of you would be willing to contribute to that effort of BGP SPF? You can now raise your hands. There's a light back there that I can't see anything. Okay. And you guys are taking some notes,
we're
right?
taking notes.
Okay. And the other question is, of course, for the other proposal, for Rift. How many of you would be willing to contribute to that effort? Again, read the drafts, discuss on the mailing list, propose enhancements, do reviews, et cetera, all the work that would be needed to be done there. Okay, now you can go raise your hand for that. Okay. And I noticed that some of you raised your hands twice, which is fine. One of the reasons that we want to do this poll is because we obviously have limited resources in the routing area, right? So you can't go to 27 working groups in a week. So it would be nice that if you do want to contribute to both efforts, if we go forward with both, that you do participate in both, and we don't end up with 3 people in one working group and 2 in the other group, right? So that's it. I think that this is what we wanted to get out of this room, right? The sense that there is, whether there is a problem or not, and if we're going to go forward with anything, this is a decision that we're going to make with the chairs and the other routing IDs hopefully soon, as to what do we do next. Do we charter something? Do we do more discussion? Do we get some more presentations on before we move somewhere else? So that's all I have. Thank you so much.
Okay, so we actually have about like 2 or 3 minutes left before the end of the time here actually. So if anybody actually has like any other comments or things they want to radiate from their hearts or whatever, now is your opportunity. Otherwise, we're going to close the session. Nobody? Okay, thank you.